Sorry. 1.2 is arithmetic series. Last unit section was on arithmetic sequence. So the only difference between a sequence and a series is that a series is formed by taking the terms of a sequence and adding them together. So we go from a sequence of 6, 10, 14, 18 to a series by putting the add signs in between. So 6 plus 10 plus 14 plus 18 plus so on. So our formula for the sum of the terms in an arithmetic sequence is S with the subscript n. So Sn is equal to n over 2 times a plus 1. And often you'll see this written in a few different ways, and all it is just a manipulation of the same formula. So don't let that confuse you. It all means the same thing. So our S stands for sum, n is the number of terms we're looking at. A plus L, A again from the last section is your first term. Sometimes they have, remember that A is the same as T1. Your last term sometimes will be written as Tn, so as the last term that you're looking for. Either way, it all means the same thing. You're adding your first and your last term, multiplying it to the number of terms divided by 2, and that gives you your sum. So example number 1. It says find the sum of 135 all the way up to 21. So what we're looking for, and remember you always identify your variables, so we're trying to find the sum of those numbers. The number of terms that we have, if we count these up, there are 11 terms there. Our first term is a 1. Our last term was 21. So this is a nice simple one because they've given you all of those things. They've given you the first and the last term, and they've told, and you can easily count to see how many numbers there are. You're going to see in some examples coming up that it's not always going to be quite so simple. You're going to have to either figure out how many terms there are, or you'll have to figure out first what is the last term if they've told you the number of terms, or figure out the first terms. So we're going to manipulate the formula a little bit. But for this one, it's just simply substituting into your formula. So we're looking for the sum of these 11 numbers. So it's 11 over 2. First number was a 1, last number was 21. So 5.5 times 22 gives us 121. Okay? Another way to write this exact same thing is to say n times a plus L all over 2. Because this is being multiplied here, it doesn't matter if you put it all over the 2 or just the n over the 2. You'll get the exact same answer. So example 2, it says sometimes when we are told to find the sum of series, we are not given all of the information. So that's what I was just saying. And you need to substitute into our original formula. In this case, we need to use our arithmetic sequence formula. And I mentioned that last day, that this Tn formula is used in many different ways to find many different things. So for example, in this one it says find the sum of 159, 13, 33. So it's given us, if we're thinking about our sum formula, we want to find the sum. It's given us our first term, it's given us our last term, but it has not told us how many terms are in between there. Now this one, because of the numbers that we have, we could count using our common difference to fill in the blanks and then find your term. But that's okay when it's a small sequence like this. But when you have large sequences, that takes too long. So what you do then is you need to find out what is the number of terms we have. So remember, this L is the same as Tn. So if we have our Tn and we have our A, we don't know how many terms there are, but we could find what D is. We can, by looking at this, figure out D. So remember, it's term 2 minus term 1, so 5 take away 1 is 4. So if I have my A, my Tn, my D, then I can find out how many terms there are by using my term formula. So my nth term was 33, my first term was 1, I don't know how many terms I have, but I know I have a common difference of 4. So by doing my math, I have 32 is equal to n minus 1 times 4. If I divide 32 by 4, I have 8 is equal to n minus 1. Add 1, so 9 is equal to n. So there are 9 terms in this formula. So that means now I have my first term, I have my last term, and now that I've solved for this, I have my n. So I can use my sum. So my n was 9 over 2, my first term was a 1, my last term was 33. So I have 4.5 times 34, which is 153. Example 3 says find the sum of the terms in the series. So I've got 12, 20, 28, all the way up to 300. So I'm trying to find my sum. My first term was 12. My last term was 300, which is the same as my nth term. I don't know how many terms I have, but I can find my common difference. 20 take away 12 is 8. So knowing that, then I can use my term formula and find out how many terms that I have. So my last term was 300, my a was 12, and my common difference was 8. If I take 12 away, I have 288 is equal to n minus 1 times 8. Divide by 8. 36 is equal to n minus 1. Add 1. 37 is equal to n. So I have 37 terms. So now I have my first, my last, and the number of terms, so I can solve for the sum. So I have 37 over 2 is equal to 12 plus 300. So 37 over 2 times 312 is 5,772. So sometimes we need to find the sum of an arithmetic sequence when the last term is not given. So sometimes we need that L, or we need that Tn to find, and in order to find the last term, it's that same as the L and the Tn substitute for each other, and we can use the term formula. So knowing this, we can substitute the above formula into our sum of a series formula as shown. So if you're not given the last term, but you are told how many terms you have, and you can figure out the common difference, and you know your first term, then you can do a manipulation of that n over 2 times a plus L. Because we know L is the same as Tn, so then that means we can just substitute the Tn formula. So instead of saying L, we're going to say Tn is equal to that. So the new formula will look like n over 2 times a plus, so instead of L, I have a plus n minus 1 d. So if I collect some common factors here, or like terms, I have a plus a, so that gives me 2a plus n minus 1 times d. Okay, can also be written as n times 2a plus n minus 1 times d all over 2. Same thing. So when you're not given the last term, but you have your first term, the number of terms, and you can find out the common difference, then you can use this manipulation of your sum formula to find it without having to go and do the two steps separately. So it says find the sum of the first 53 terms of the series 55 plus 60 plus 65 plus 70, and so on. So this has told me what my a is, It's told me that there are 53 terms. I can figure out my common difference because 60 take away 55 is 5. I don't know my last term, but because I know these three, I can use this manipulated formula to find out my answer. So n is equal to 53 times 2 times a was 55 plus 53 take away 1 times 5, and I'm going to divide all of that by 2. So I have 53 times 110 plus 52 times 5 is 260 all over 2. So 53 times 110 plus 260 divided by 2 is 9,805. So the next example, same thing. It says find the sum of the first 8 terms in the sequence -9, -5, -1. So I have my A, it's -9. I know I'm looking at 8 terms in total. I know my common difference. I go -5 minus -9, so that leaves me with 4. My last term, don't know, but I can, because I have these 3, I can substitute into my sum formula, my manipulated sum formula, to have 8 times 2 times -9 plus 8 minus 1 times 4, and that's all over 2. So it's 8 times -18 plus 8 times -1 is 7 times 4 is 28 all over 2. So 8 times 10 is 80 divided by 2 is 40. So that's all there is for the examples here. So the biggest thing to remember is you can do what I've done here in these 2 examples. You can do them separately by finding the Tn first, by finding that last term, and then substituting into n over 2 times a plus l, or you can manipulate the formula into this 2a plus n minus 1d divided by 2 and do all the calculations at once. Either way is okay. The second way here that I've shown you just takes a few less steps for you. So that's all there is for this section. You can do the questions. Good luck.